Now that we're comfortable with logarithms and using logs to solve equations, we can use logs to solve various exponential applications in the real world. So for example, if a doctor gave you 15 milligrams of some radioactive dye for some test, and 6 minutes later there's 7.2 milligrams remaining in your system, we want to know how long until there's less than 2 milligrams left in your system. What we have here is your kidneys and liver are going to filter out a certain percentage of the radioactive dye every so many minutes. We need to do some work to figure out what that constant multiplier or rate of decay is. And we know that exponential functions, f of t, t for time, because we're talking about how many minutes, is equal to a b to the t power. And you might remember that a is the starting value and b is the multiplier. Now, we're going to have to do a little bit of trick mathematics, for lack of a better term, to figure out what b is. It's not going to be too difficult, though. We do know, to start off with, we had 15 milligrams of the dye at the start, so that's got to be our a. 6 minutes, that's the amount of time that's passed to give us a final result, f of t, of 7.2 milligrams. So when we plug this information in, the final result of 7.2 milligrams is equal to the starting value of 15. We just need to find b. T, we know the time is 6. So now we have an equation we can solve to figure out what b is. First, we'll divide by the 15 to get the b alone. And we're going to have to do some rounding as we get through this. I'm going to round to 5 decimal places while we're doing work, and we'll round to 2 decimal places at the end. So we've got 7.2 divided by 15. That's actually not too bad yet. That's 0.48 equals b to the 6th. And then we have to get rid of that 6th power. One way to get rid of 6th power is to raise it to what we call the reciprocal exponent. If I raise it to the 1/6 power, and we have to do the same thing on both sides, you'll notice 6 times 1/6 is just 1, and that goes away. So all I have to do is take that 4.48 on my calculator and raise it to the 1/6 power, 1 over 6, and I find out that b is equal to, actually, let's just round it to 4 decimal places, 0.8849, 88.49% every minute. So now that I know what b is, and we know what a is, we actually know what our function truly looks like. Our function is our starting value, the 15 milligrams, times b, the 0.8849 raised to the t power. Now we have a function we can solve for our variable. The question we're answering is how long until we have 2 milligrams left in your system. That 2 milligrams is the final amount, so we're solving 2 equals 15 times 0.8849 to the t power. We know when we're solving exponentials, we need to get the exponent part alone by itself, so we're going to divide both sides by the 15. And 2 over 15 is going to be an ugly decimal. 2/15 is 0.1333, rounding to 4 decimal points, equals 0.8849, all to the t power. Now we're ready to take the log of both sides to get that t out of the exponent and in front of the log. So we have the log of 0.1333 equals t times the log of 0.8849. And we're just one step away from getting the t alone. Divide both sides by the log of 0.8849. And t is finally alone. We just have to type it into our calculator to learn how long until there's 2 milligrams left in your system. The log of 0.1333. Making sure you're careful of parentheses and where they're needed on your calculator, because every calculator is a little different. Divided by the log of 0.8849. And we have 16.48. We'll say 16.48 minutes. After about 16.5 minutes, there are less than 2 milligrams left in your system. And that's how we can use a log to solve for the question of how long until. Here's another problem. We've got a stock that increases. Well, first, the stock is worth $120. It's increasing at a rate of 12% per year. How long till the stock doubles in value? First, we need an equation. Our standard equation, f of t is equal to a b to the t power, where t is the time and f of t is the final amount. $120? What information is that in our problem? That's the starting value, which we know the starting value is the a. What about the 12%? It's increasing 12% per year. And remember, when we're increasing by a percent, that's our change, that's our b, but it has to be a parentheses 1 plus the increase, 1 plus 0.12, or 1.12 for our b. So now we know our equation is f of t equals the starting value of 120 times 1.12 raised to the t power. Now that we have our equation, we're ready to answer our question. How long, we're looking for time, we're looking for t, until the stock doubles. Well, when it doubles, what's it worth? It started at 120. We want to double it. It's going to be worth 240 at the double point. So our final amount is $240. Equals the 120 times 1.12 raised to the t power. We can solve this really quick with a logarithm. First, we know we have to get the exponent alone. Then we take the log of both sides. Right now the 120 is in the way, so we'll divide both sides by 120. When we do, we get 2 equals 1.12 to the t power. And then take that log of base 10 of both sides. Because when we take the log, that exponent of t is going to move out front. So the log of 2 equals t times the log of 1.12. We want the t alone, so to undo the multiplication, we divide by the log of 1.12 on both sides. And now we will know how long it's going to take my stock to double at 12% per year. On my calculator, I just have to make sure I type it all in correctly, being aware of parentheses that might be needed in various places. The log of 2 divided by the log of 1.12. Time is equal to 6.12. We'll round it to 2 decimal places. 6.12 years. Just over 6 years, my stock will have doubled in value. Now, a real common application of exponents is in what's called compound interest. Compound interest basically means you can earn interest on your interest. What that means is basically if you invest $100 at 10%, well, 10% of $100 is $10. So after the first payout, you'll have $110. But now that $110 is at 10%, and so now your payout the second round 10% of 110 is $11. So you make more money. You make interest on your interest with compound interest. It accumulates faster the longer you leave it there. The idea is if you put money in the bank, you get money back from the bank. It's a good deal. In fact, Albert Einstein supposedly said that compound interest is one of the most powerful forces in the universe. Those that do not understand it pay compound interest, and those that do understand it receive compound interest. It's a great way to make $1 million in a reasonable amount of time. So what we're looking at today is the general formula for compound interest. This is a good formula to be aware of, not just in this class, but this is how your student loan debt works, your car debt works, your home loan works. This is the formula for the amount. F of x is equal to P. P stands for the principal. Let's see if we can color code this. P stands for the principal or the starting amount. Then there's this R, and the yellow's kind of making it weird. I'm going to get rid of the yellow. There we go. R is the interest rate, what percent you're making on your account as a decimal. N, and you'll notice that the N appears in two places, once in the denominator and once in the exponent. N is the number of compounds per year. So if you have something that's compounded monthly, that means they pay interest every month, but they divide it up over the 12 months. So N would be 12. Sometimes they pay quarterly, so they would divide it by 4. N is the number of compounds per year. And finally, the variable everybody's interested in is T, time. How long does it take until I have as much money as I want? F of x equals P times 1 plus R over N to the NT power. So, let's do an example. And just to help us out here, I'm going to write the formula again up here. F of T time is equal to P times 1 plus R over N raised to the NT power. So we have $250. We want it to grow to $350, invested at 7.5%, compounded quarterly. Let's see what we have for the pieces. First, the $250. That's the starting amount. That is the P. We want it to grow to $350. That's the final amount. That's the F of T that we're going to end up with. Often you see it's R of T, but that's okay. We've got this 7.5%. 7.5%, that is the interest rate, or how much money it's paying. So R is 7.5%, but as a decimal, so it's 0.075. Be careful not to put it in as 7.5%. That represents 750%. Not quite the same. And it's compounded quarterly. How many quarters in a year? That's the number of compounds in a year. There's 4 in a year. So that is the N in this equation. So if we plug all that into our formula, F of T, let's see if I can keep the same colors. F of T, the 350, is going to equal the principal or starting amount of $250 times 1 plus R, the interest rate, which is 0.075, divided by N, the number of compounds, which is 4. All of that raised to the NT, and N again, and still is 4. T, and I'm going to put the T after it, just like we normally see, 4T. There we go. So this is the equation we want to solve. So, how do we start solving this? First thing we want to do is we need to get the part with the exponent alone. So we have 250 times that multiplier. So we get rid of that 250 by dividing both sides by 250. And when we do that on our calculator, 350 divided by 250 is 1.4 equals. I'm also going to simplify this parentheses stuff just to make life easy for us. 1 plus 0.075 divided by 4 is, and I'm going to keep all these decimals for accuracy's sake, 1.01875, and that's raised to the 4t power. And there's a lot of decimals, but this should look very familiar to us. We've got the variable in the exponent, so we know we have to take the log of both sides in order to solve. When we do, that exponent's going to move out front. So we have the log of 1.4 equals 4t times the log of 1.01875. We want to get the t alone, so we divide out what t is multiplied by. It's multiplied by a 4, and it's also multiplied by the log of 1.01875. So we'll do that on both sides. 1.01875. So the logs are gone, the 4 is gone. All that's left is the t, the amount of time it's going to take my investment to grow compounded quarterly to $350. Be very careful of parentheses. You might need an extra set of parentheses around the denominator in your calculator. The log of 1.4, close the parentheses, divided by a parentheses for the denominator, 4 times the log of 1.01875, close the parentheses, and we're going to round that to 4.53 years. In 4.53 years, this investment has grown from $250 to $350. So that's how we can use the applications of exponential and logarithmic functions. There's a lot of different kinds, but really at the heart, they're all basically the same. So take a look at the homework assignment and give those a good practice, and let your instructor know if you have any questions.